Okay, this is section 1.6, and we're going to be solving compound and absolute value inequalities. And we kind of talked about this yesterday when we learned how to write interval notation and set builder notation. So a compound inequality consists of two inequalities joined by the word and or the word or. So just like in English, when you learn about compound sentences, they're joined with and or or. And to solve a compound inequality, you must solve each part of the inequality. And the graph of a compound inequality containing and is the intersection of the solution sets of the two inequalities. So we're going to see what that looks like. So here's example one. This is a compound inequality, and it looks different than our other ones because I have two inequality signs. Okay, so on this problem, anytime you see, and I'm going to write it out a little bigger, 8 is less than 3y minus 7 is less than or equal to 23. Anytime you see something like this compound inequality, this was a compound inequality with the word and in between. Okay, it was the intersection of two solution sets. So I'm going to show you how you can solve this. I could break this up into two separate inequalities, but you can leave it just like this and it's going to be just as easy. So what I want to do is I want to solve for y. So I want y all by itself, just like we've always done. But this time, whenever I do something, I don't know why it does that, I'm sorry. Okay, whenever I do something like add 7, I have to add 7 across this side and over here on this side. So I'm going to do it instead of twice, I'm going to do it on all three sides. So here's what it looks like. I want to solve for y, and it's 3y minus 7, so I need to add 7. I need to get rid of the 7. So I'm going to add 7 here, which means I need to add 7 over here. And then I also need to go over here across this inequality side and add 7. So now when I do that, 8 plus 7 is 15, is less than 3y, those cancel, is less than or equal to 30. Now I'm still solving for y, so I need to get rid of this 3. That's 3 times y, so I need to divide by 3. So I'm going to divide everything by 3. So 15 divided by 3 is 5, is less than, these 3's cancel, and I have y is less than or equal to 30 divided by 3, 10. Now, this is a compound inequality, and we graphed some of these yesterday. If I had a number line, and I went from 4, 5, 6, 7, 8, 9, 10, 11. Okay, and I need to graph this. Whoops. What is my starting point? Well, my starting point is 5, and I want all the numbers between 5 and my end point, which is 10. So I'm going to go to 5 and circle it. It's going to be an open circle because it's not also equal to. I'm going to go to 10, and it's going to be a closed circle because it's also equal to, and it's all these numbers in the middle. If I wanted to write this in interval notation, which they don't ask us to do that, but remember we would write it as 5. Whoops, I did that wrong. Let me erase that. Okay, interval notation would look like this. Parenthesis 5, 10 would be a bracket because it's open at 5, closed at 10. Okay, so that's example 1. Example 2. The graph of a compound inequality containing or is the union of the solution sets of the two inequalities. All right, so I have two problems to solve. I have k plus 6 is less than negative 4, or 3k is greater than or equal to 14. All right, so whenever I graph this, or whenever I solve, I'm going to graph both of these things on the same line. Okay, and I'm just going to join their graphs together. So first I have to solve. I'm going to subtract 6. Subtract 6. So k is less than negative 10, or divide by 3, k is greater than or equal to 14 divided by 3. And if you're wondering what 14 divided by 3 is, that's like 4 and 2/3. Okay, so 4.6. I'm going to write that in so you can kind of tell where it goes in the number line. All right, so when I graph this, I know my smallest number is -10. Okay, I'm going to go by fives. -5, 0, 5, 10, 15. So when I graph this, I'm just going to unite or put their graphs all in the same graph. So this one, I'm going to go to 10. It's an open circle, and it's to the left. 14 over 3 was 4.6, so it's not quite to 5. It's going to be an open circle, and it's going to be pointing to the right. All right, let's look at the next thing. Okay, so this was out of your book on page 43. It says solve each inequality, graph the solution set on a number line. Now they're going to introduce absolute values with inequalities. Okay, the absolute value of x is less than 3 means that the distance right here, this distance between x and 0 number line, is less than 3 units. So to make the absolute value of x is less than 3 true, okay, I want all the numbers on the number line that are less than 3 units away from 0. So do you see that these would be those points? The distance from 0, I'm going to go up to 3, but not including 3, and this way to 3. So the distance away from 0 is less than 3. Okay, so all the numbers between -3 and 3 are less than 3 units from 0. So the solution set is, and then they wrote it out in interval notation. I'm sorry, I don't know why that keeps happening. And then this way, in part B, the absolute value of x is greater than 5, means that the distance between x and 0 on a number line is more than 5 units. So to make this true, I'm going to start at 5, but it's going to go the opposite direction because I want all the numbers that their distance is greater than 5 units. All right, so all the numbers between and including -5 and 5 are no more than 5 units, so they are not part of the solution set. So the solution set, they wrote it here in interval notation, -∞ to -5, unioned with 5 to infinity. Okay, so the next thing on your notes is, this is what you really need to concentrate on. When solving absolute value inequalities, and you have a less than, that is going to be an and problem. When solving absolute value inequalities that have a greater than, you're going to have an or in between. And I'm going to show you what I'm talking about. So first of all, I have an absolute value, and it's an inequality. It's greater than. So looking back at your notes, greater than, I'm going to connect with the word or. So greater than or greater than or equal to. Connect with the word or. So I need to write my two problems because remember absolute value problems always have two problems that you work out. Here's my first one. 6y minus 5 is greater than or equal to 13. Or, now I need to write my second one. 6y minus 5. Remember we changed the sign on my second number? But when I change the sign, I also need to change the sign of my inequality. Because if this becomes negative, that means I had to multiply or divide by negative. So this sign is going to change. So now I'm going to solve these. Okay, so the first thing I'm going to do is add 5. So I'm going to add 5 here, add 5. 6y is greater than or equal to 18. Divide by 6. So y is greater than or equal to 3. Or solve this one. Add 5, add 5. 6y is less than or equal to -8. Divide by 6. So y is less than or equal to -8 over 6, but that reduces down to -4 over 3. Okay, so now I need to graph this. So when I graph this, Okay, I know this is negative 1 and 1/3. So I'm going to start with negative 2, negative 1, 0, 1, 2, 3. All right, so let's do this one first. Y is greater than or equal to 3. So when I graph that, I'm going to go to 3. It's a closed circle. And Y is greater than, so it's going to be pointing this way. This, I'm going to go to negative 4/3. Negative 4/3 is negative 1 and 1/3, so it's a little bit past negative 1. It's going to be a closed circle. And this one's Y is to the left, Y is less than, so I want to the left. And that is my solution. If I wrote that in interval notation like we did yesterday, it would be negative infinity to negative 4/3 unioned with 3 to infinity. All right, let's do this one. I have absolute value, so I know I'm going to have two problems to solve. Okay, it's less than or equal to, so less than will be connected with the word and. So I have 5z plus 2 is less than or equal to 17, and 5z plus 2 is greater than or equal to, I had to switch that sign, negative 17. Now, and problems we can write differently. Remember this first problem that we had, if I can find it. Let's see here. I'll go back and find it. Remember this? This was an and problem. See how it was written? We want to write our and problems like that. So I'm going to write this as a compound inequality. And here's what you do. What they have in common will go in the middle. 5z plus 2. Okay, now if you write it correctly, your larger number, so 17 or negative 17, your larger number should go on the right-hand side. And if I'm, see how this matches up with this? And then my smaller number is going to go on the left-hand side. And see when I wrote this over here, see how I just flipped this around? So if I cover this part up, if I don't look at this, isn't this part right here the same as this, just flipped? So now this is my new problem and I'm going to solve that. So I want z all by itself. So I'm going to get rid of this 2 by subtracting 2 from both sides. So I have negative 19 is less than or equal to 5z is less than or equal to 15. So now I'm going to get rid of this 5 by dividing everything by 5. So I have negative 19 over 5, that doesn't go evenly, so we can just leave it, is less than or equal to z is less than or equal to 3. Okay, and now I'm going to graph that. So negative 19 over 5, do you know what that is? 19 over 5 is 3.8. So this is negative 3.8. So I'm going to start here at negative 4, negative 3, negative 2, negative 1, 0, 1, 2, 3. Okay, so I'm going to start at negative 3.8 because that's what this is. It's going to be a closed circle. I'm going to go to 3 and it's a closed circle. And then it's what they have in between. Okay. All right. I'm going to stop right there. There are some problems that you're going to have on your worksheet that we will need to work together. Okay. So for right now, this should be enough to get you started. And then I want you to start on your worksheet. And as you start working, I want you to pick together as a class 2 or 3 problems that you want me to work together. Because some of these on your worksheet, you might have something that you can't solve and you won't have anything to graph. Okay, so I'll look at the worksheet, see if I can figure out which ones are going to be kind of weird, and I will post another video over those. Okay, so for right now, go ahead and start on your worksheets, and then I will post another video whenever I find something that's kind of weird.